With this video, I would like to explain a little bit more about the functioning of the Excel spreadsheet that I developed for the design of the Stewart platform. In the current view, you see an isometric view of CAD simulated Stewart platform. The red lines indicate the physical displacement between the lower pivot points of the base as well as the top pivot points of the platform. The green line represents the physical length of the connecting rod between the top pivot point and the bottom servo arm. The servo arm itself is indicated by the blue line. In this particular movement, you can see the servo arms moving up and down, moving the physical connecting rods, the green lines, up and down, pushing the platform up and down. This results in a displacement between the top and the bottom pivot points represented by the red lines. In the same fashion, you can move the platform left and right, forward, backwards along the y-axis, as well as up and down along the z-axis. Pitch angle, rotation about the z-axis, rotation about the y-axis called roll, as well as rotation about the z-axis called the yaw. Should any one of the movements that you require the platform to do fall outside the physical constraints or the mechanical constraints of the structure, an error will be generated, indicated by the table in the top right hand corner. There is an example of server number 3 not being able to result in the position that is required by the parameters. There are a few push buttons which act on some saved macros. This particular button homes the platform or resets all the parameters to 0. With these 4 buttons you can set the view of the graph to view it from the point of the z-axis, the x or the y, or set it to isometric view. That's viewed from the top, viewed from the front, viewed from the left. And with each different view you can see or have a better perspective of the movement. So if you view it from the point of the y-axis, x movement is much more apparent or evident. If should you move the y parameter while you're looking directly into the y-axis, you will see no movement. You can also select to view isometric, or you can change the angle from which you view it manually by changing the parameters at the top. That will rotate the cage around the x-axis. This parameter will rotate around the y-axis as well as the z-axis. In the next sheet you can set up the parameters that defines the shape of the Stewart platform. Most importantly, the size of the top platform and the size of the bottom platform is defined by RD and PD, radius of the top platform and the radius of the base. So quickly editing, make the radius of the top platform 20 units and the radius of the bottom platform 100 units. And the result is quite self-explanatory. The platform joint angle, as you can see in this graph here, the top view of the Stewart platform, there's a virtual line running across the 30-degree axis, the 150-degree axis, as well as the 270-degree axis. The base and the top platform pivot points work on offsets. In this case, the platform joint angle is set to a 15-degree angle. In other words, this connecting point is 15 degrees before 30 degrees, and this point is 15 degrees after 30 degrees. By changing that to 0, both points will lie directly on the 30 degree line, spaced 120 degrees around the Cartesian coordinate system. Changing it back to 15. The same applies for the base pivot points. The next important parameter, depending on the mechanical design of your structure, is the length of the servo arm. That is, the blue line in this graph connect between the servo axis and the physical connecting rod. Should that axis be a little longer or shorter, the parameter L1 is adjusted. Should the green line be longer or shorter, L2 is adjusted. Z home indicates where your position of the top platform is in its 0 position, or if you choose it to be the position where your servo arms lie at the horizontal. Another important factor to consider is the angle at which your servo axis lies. As you can see from where my cursor is hovering, servo number 1 and servo number 6 is connected with the servo arms in one single plane. Should you change the angle at which servo number 1 connects to the servo arm, which currently is on the 0 axis, should you change it to some other angle, 150 degrees, you will see that the line connecting the blue dot here and the green dot is now lying at 150 degrees. And when there's movement, it will move up and down within that plane. Same applies for all the other servos. If you want axis or servo number 6 to lie at 30 degrees, 30 degrees is entered, and it will result in the movement acting about the 30 degree axis. That sort of sums up the mechanical simulation of the steered platform by means of the Excel spreadsheet.